A very good afternoon to all. Welcome back to our course on the C programming language. In this session, I am going to discuss about one of the very important concept, which is the differences between the structures and unions. In the previous sessions, we have discussed a lot of topics related to structures and unions, and we have seen that both these structures and unions, they come under the category of user-defined data type. And in today's session, we'll see what exactly are the differences between these structures and the unions. The first difference what I would like to discuss under these structures versus unions is the keyword, what we are going to use for the structures as well as the unions. So while defining the structures, we'll be using a keyword called struct. And while defining the unions, we'll be using the keyword called union. So this is the first difference between the structures and unions, where the keyword for defining the structures is struct and the keyword for defining the union is the union. And coming to the second most important difference, that is memory allocation. Memory allocation. Under this, we have seen that the total memory allocated for structure, memory for structure, is equal to sum of the memories allocated for different data members. But whereas if you consider the memory allocated for the unions, so the memory for union is equal to the memory that is allocated for the maximum element. So memory allocated for maximum member. So who is going to have the maximum memory allocation? That member's memory size will be allocated for the unions. And in the third case also, we will look at the same concept of memory allocation only, but this is something different. We are not going to discuss about the sizes here. We are going to discuss whether the memory is allocated for all the members or not. So if you consider the structures, memory allocation happens for every data member of the structure. So every data member of the structure will have his or his own memory locations. And in similar case, if you consider the memory allocation that is allocated for the data members of the structure of the unions, here memory will be allocated for only one member. One data member will be allocated memory. That means here you can say that every data member is having, in structures, every data member is having unique storage. Whereas in the unions, we say that memory is allocated for only one data member and that will be shared by all the members. So here we have the shared storage. This is the important point, most important point regarding these structures and unions. And when you want to discuss the next point is alteration. The alteration in the sense, when you assign some value to a member of the structure, whether it is going to affect the other members or not. Since the structures data members have unique storage for each and every data member, allocation or giving some value or storing some value in one data member will not affect the other data members. So there will not be the allocation of values for one data member will not be affecting the other members. And similarly, if you consider the concept of unions, we know that one shared storage will be assigned for all the members of the union. Therefore, when you are storing values in one data member, it will definitely affect the other members. We have seen it in the previous example also, in the previous sessions. So this will have effect on other members. And coming to accessing of members, since every member of the structure is having his own memory storage or unique storage, you can access all the members at a time. So I have given it in the previous discussion also, all at a time can be accessed. But when you consider the concept of unions, since only the maximum member will be allocated and it is the shared storage, only one member at a time can be accessed. So one at a time can be accessed. And the last difference what we can give under these structures and unions is initialization. When you want to initialize a structure, you can initialize all the members of the structure. But when you want to initialize the union, you cannot do the initialization for all the members, but you can only initialize the first item or the first member of the union. So for example, if you have the first item as int and then you have char, let me take the previous example, union student, and I have registration number and I have gender here, and then I have double like this CGPA. If this is the case, when I want to initialize this union member, I can do it like this: union student S1 is equal to, you can give some value, and that value should be only integer. Why? Because the first data member is the registration number, that only you can initialize, and the first data member registration number is of type integer, so you can initialize it to only one value, that is 501, which is integer data type. But if you consider the same concept of structures here, so this is all about the initialization of union. If you take the same concept of structures, we can initialize all the members like this. For example, assume that I have the same struct student with these three members, that int registration number, char gender and double CGPA. I can create a variable of type struct like struct student S1, and initialization should be accompanied with an assignment, declaration plus assignment, and you have to give all the list of values 501, and let me take it as male, and let me take the CGPA as 9.4. So you can see here that the first member registration number as well as the second member gender and the third member CGPA can be initialized. Why? Because every member is having unique storage. The storage itself plays very important role. Whereas in these unions, since we have shared storage for every member, we can initialize only the first member, and later if you want to initialize the other members gender and CGPA, you can do it individually, like S1 dot gender is equal to F. So the previous value 501 will be overwritten by this F. This everything we have seen in the previous discussions. And coming to the advantages of structures and unions, the last point, which is going to save more memory, means obviously the answer will be unions. Why? Because while you are making use of unions, the compiler is going to make or allocate the memory for the largest member. So here in the same example what we take here, it will be 4, this is 1 and this is 8. So in unions 8 bytes of memory will be allocated, whereas if you take the same concept with the structures, it will allocate 13 bytes. So 8 bytes for union and 13 bytes for the structure. So obviously we can say that unions can be used whenever you want to conserve the memory or whenever you want to save some memory. So when you want to use the memory in a very restricted manner or in a very saving mode, then you can go for the concept of unions. Otherwise you can go for the concept of structures, where we have more advantages in the structures. Why? Because they have unique storage for each and every member. So that's all about the differences between the structures and unions, a very important concept in the C programming language. So we have started our discussion with the keywords that are used to define the structure and union. Then the memory allocation, based points like memory allocated for struct is equal to sum of memories allocated for all the individual different data members, and memory allocated for union is equal to memory allocated for maximum member. And next, every data member of structure will have his own storage, whereas only one data member of the union will have the storage. So we call it as the unique storage for every data member in the structures, whereas it is a shared storage in the case of unions. And alteration, when you make alterations to any of the data member, it will not affect the other members in the structures, but it will have definitely the bad effects on the other members if you alter the values of other members. And accessing can be done all at a time in case of structures, and only one member can be accessed at a time in unions. And initialization can be done to all members at a time in the structures, whereas only the first member can be initialized in the unions. And finally we have seen that unions are best suited whenever you have some constraints on the memory. Whenever you want to save the memory, the best choice is you can go for the unions, otherwise you can choose the structures. So that's all about the structures versus unions. Thank you one and all for joining the session.